Greetings to the viewer, this is Jashandeep Sethi right here, and in this video I'll be solving question 3 of MAT 104 Endterm examination. So let's begin. Yes, so the given ODE for mass spring system is this. Let me just focus it. Yes, so the given ODE is y double dash plus 25y is equals to 24 sin t. And we have been asked to find the solution as well as plot the graph for the solution curve. So we know one thing, that the general equation for a system is y double dash ay double dash plus by dash plus cy is equals to dgt. Now we also know that the transient motion, that is the simply the transient motion of mass spring system is given by y equals to y homogeneous plus y particular. Right, now we're going to find the general solution for equation for basically y double dash plus 25y equals to 0. Let's just call this equation as 1. Now you might ask that why is this 0 here? Now one thing we know about homogeneous equation is that the gt in a homogeneous equation becomes 0, and in our given ODE the gt is sin t, so sin t becomes 0 and this entire terms becomes 0. So this leads us to this final equation, that is y double dash plus 25y equals to 0, right? So let y homogeneous equals to a cos mt plus b sin mt. Right, so let's just differentiate this once, and on single differentiation what we get is m into minus a sin mt. Since we are differentiating this inside term, so we'll be getting m in both of these terms, hence I have taken m common in the very beginning, plus b cos mt. Right, so let us just differentiate this once again. So double differentiation would be, we'll again get an m common, so that will be m square, and this would be a cos mt, and here we're differentiating this cos, so we'll get minus sin sin mt. Right, now we can take this minus sign outside, so it will be y double dash h equals to minus m square, and we can see this inside term, when we take the minus sign common outside, is nothing but the initial yh, so it's initial y homogeneous. So let's just call this equation 2. Now what we're going to do is we're going to simply compare the first and the second equation, that is we're going to put the values in first equation and get, so comparing 1 and 2, we put the value and we get m minus m square yh equals to minus 25 yh. So we are left with m square equals to 25, which is basically m equals to plus minus 5. Therefore y homogeneous is nothing but a cos 5t plus b sin 5t. We'll just simply put this value of m or value of m in the initial equation of y homogeneous. So this equation we call as third. Now let me just focus this. Okay, now steady state oscillation, I am writing along so I'll be speaking at a slower pace. Oscillation of a mass spring system is given by y particular equals to c cos t plus d sin t. Let's call this equation as fourth. So double derivative of y would be simply minus yp. You can calculate this. In the end we'll get this only, that the double derivative of yp is basically nothing but minus yp. So what we're going to land up with is now y double dash plus 25 yp is equals to 24 sin t from the initial equation, from the one that we were given in the beginning. So we get yp equals to sin t. Let's call this equation as fifth. Now you might be asking, how did we get this yp equals to sin t? All we did was put the value of y double dash from this equation minus yp. So we got 24 yp, which is equals to 24 sin t. The 24 on both sides got cancelled and we are left with yp equals to sin t. So what we're going to simply do is we're going to compare equation 4 and 5. On comparing fourth and fifth equation, that is this equation and this equation, we get c equals to 0 and d equals to 1. That is obvious, you can see that very clearly. Now y equals to y homogeneous plus y particular. This was obviously, I provided this in the very beginning, is nothing but a cos 5t plus b sin 5t plus sin t. How did we get this? We had found out the y homogeneous here, right? This equation, this y homogeneous equation, and here we found out the y particular. So all we did was just simply, here we found out the y particular, and all we did was just simply add them, right? So now from the initial value problem, we have been provided that y at 0 is 1 and y prime, that is y dash, at 0 is also equals to 1. So if we put time as 0 in this equation, what we'll receive is basically a equals to 1, and if we put y dash as 0, that is time as 0 in y dash, what we're going to simply get is 5b plus 1 equals to 1. So this would further result in 5b equals to 0, hence b equals to 0. Thus we conclude with the final equation as y equals to cos 5t plus sin t. So this is our final equation. Let me just underline this. Now we also have to, the question also asks us to plot the graph of this equation. So we know that y particular is nothing but sin t, and y dash would become cos t. That is all but the velocity of the spring system. So let me just draw the spring system here. It'll be easier for you to understand. So this is our spring system and here is our mass. Now naturally the spring system never comes to a steady state, but let's say that it is coming to a steady state momentarily. This would happen when the velocity of the mass is 0. So when the velocity is 0 for like y particular, the graph is obviously a sinusoidal graph. So the graph would be a very normal sinusoidal graph. And for y dash, the velocity, the graph would be a cos graph, a cosine graph. So it will be something like this. I hope I'm drawing it correctly. It will be something like this, right? So this is the graph. This graph is for y dash, and this graph is for y. Now, our final equation was cos 5t. We can see it right here. It was cos 5t plus sine t. Right now, plotting the graph for our final equation is slightly difficult by hand. So I used an online software, graphing software, to plot the graph. So I'll show you the graph on my PC. So here is the graph. Let me just pull it a little back. Okay. So here is the graph for our final equation, and here we can see very clearly that it is not becoming 0, but it seems to be 0 at certain points. So and it becomes maximum at roughly somewhere around 1.3, I guess. So this is the final graph of our solution, and I think so that is pretty much it. Hope you were able to understand the question via my solution. Thank you for viewing. Have a good day.